Good morning. This morning we're going to talk about how to use a TI-84 calculator to do some statistics. This won't be of interest to all of you, but maybe there'll be something to learn even if you don't plan to do this, if you just watch the video. Maybe you'll be able to help somebody else with it. So I've got several practice problems laid out over here on the right-hand side. The first is an area problem. If we have a z distribution, and if we know that we want the boundary to be 0.68, that is from negative infinity up to 0.68 under that curve, what is the area? Now, we also know that that's exactly the same as asking about the probability that z is less than 0.68. So let's get out a calculator and see if we can figure that out. Now I should have a calculator just pop up as if by magic. There it is. Was that magic? Maybe that was magic. This is a TI-84 Plus Silver Edition. There are minor variations with the different families, but they're pretty much similar. The keyboard's the same, the key layout's pretty much the same, and the programs that we use are identical. The program we want to use here would be the normal CDF. Now I would get the normal CDF if I would go to, you see the distribution in blue right here above the vars key? That's blue, so I have to push the second and the key, and that gives me a menu of possible distributions that I might want to be invoking right now. The normal PDF would give me the height of this curve above 0.68. That's not really useful to me right now, but the normal CDF would give me the area from negative infinity up to this boundary point, and that's exactly what I want. So I see that that's function 2. So let's select function 2 by just touching the 2 key. Now on the TI-84 Plus, we've got a menu here that prompts us for the information that the calculator needs before it can calculate that area. And it's very sensible. It needs to know the lower boundary. Well, that would be negative infinity. On this calculator, negative infinity is -1. The e means times 10 to the power 99. So -1 times 10 to the power 99. That would be a value way off down here to the left. Essentially negative infinity. So that's the way the TI-84 indicates negative infinity. Positive infinity, by the way, would be +1 e 99. So just keep that in mind. There's my lower or left-hand boundary. My upper boundary is 0.68. What distribution are we talking about? We're talking about a standard normal. So the mean is 0 and the standard deviation is 1. Now I've already got those entered, but if they were different, we'd have to change them right now just by typing in. And then the last thing on this screen is paste. So that'll take the information that we've given the calculator and put it back in our computation screen. So let's arrow down, arrow down, arrow down till we get to paste, and then we'll press the enter key. And what we have asked for is now in our computation screen. Now it's a little too wide to fit across the whole screen, so you don't see all of it. I'm going to arrow over so that we can see the left-hand part of this command. I hope you already know what it looks like. We ask for the normal CDF and then a parentheses. Now let's start back. The first parameter is the left-hand boundary, -1 e 99 or negative infinity. That's followed by a comma, and then the second entry is the right-hand boundary, 0.68, followed by a comma, and the mean, and followed by a comma, and the standard deviation. And I'm putting some emphasis on that right now because some of the calculators in this family will let you select normal CDF, but won't prompt you for the parameters that go inside the parentheses. If that's the case, you have to know what the parameters are and the order in which they're required. And for the normal CDF, the parameters are going to be left-hand boundary, right-hand boundary, the mean of the distribution, and the standard deviation. Whether you enter that with the help of menus or just by remembering, we've got the command entered. We'll now press enter, and we see that the missing area is 0.7517, and then more decimal digits than we really need. Now, for the next problem, let's do the inverse. The inverse would be where we know an area under this curve, and we want to pick up a boundary. So if the area under the curve is 0.26, and if our problem is to find that boundary point, then we'd use the inverse normal. So let's see how that looks. So I'm going to select second, and then the distribution again. And now I'm going to use inverse normal, which is function 3. So let's touch the 3 key. And now the inverse normal asks for the area. Now, for this application, this works very much like what we're used to in Minitab. The area refers to the area to the left. And the area to the left is 0.26, 0.26. And again, it's a standard normal, so the default here is a 0 for the mean and a 1 for the standard deviation. That's a standard normal or a z distribution. That still has to be changed because I see that in this application, we're talking about a distribution that's normal with a mean of 20 and a standard deviation of 4. So let's go to the mean and make it 20 instead of 0. And the standard deviation, well, the standard deviation should be 4. And I think that's everything. So let's paste that into our work area by pressing the enter key. And this is going to be the inverse norm. You don't see inverse because it's off over to the left. I know you'll trust me on that one. We're ready to press the enter key, and the enter key tells me that this boundary point right here is 17.4266. Where the question mark is, that would be 17.43, and if we look at the area under the curve between negative infinity and 17.43, that area would be 0.26. So that's how we work the inverse problem. Now in our upcoming exam, the only other distribution we know about by name would be a binomial. So let's suppose that we have a binomial distribution with a mean of, with an n of 25 and a p of 0.25. Remember, in this notation, the b means binomial. The 25 would be the number of independent repeated trials, and the 0.25 over here would be the p, or the probability of success. So this would be a binomial that would be appropriate if we were taking an exam of 25 questions. Each question has 4 responses, and we have to answer purely by guessing. So the probability of getting a correct answer would be 0.25. Now let's calculate the probability of getting exactly 6 answers correct. So what we need is a binomial distribution. Well, it's a distribution, so let's say second distribution. Now, binomial is not on this screen, but this little down arrow over here tells me there is more. So I can click down, 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 and down again. And you see now we've got a binomial PDF. Let me just to show you what else is there. Let's just go down a little more. I've got a binomial PDF and a binomial CDF. Now the PDF, remember binomial is a discrete distribution, so the PDF I would use for calculating individual probabilities, the CDF for cumulative probabilities. So it looks like we want A, the binomial PDF, because I want x equal 6. So I can either arrow up to that, or I could use the keypad and put in an A. I just arrowed up to it. So let's press enter. And these are the questions that have to be asked in order to use the binomial PDF. How many trials? Well, the number of trials in this instance is 25. What's the p-value? The p-value in this instance is 0.25, or 1/4. What's the x value? The x value is x equal what? X equals 6. So we'll touch a 6, and now we'll paste, press enter. This is the binomial PDF. Now what is expected and what's the order? Well, the number of repeated trials, the probability of success, and the number of successes that we're looking for in this problem. And let's press enter. And it tells me that there's an 18% probability that the number correct will be exactly 6. Now we'll ask the next question, what's the probability that it's less than or equal to 6, that I would get none correct, or 1, or 2, or 3, or 4, or 5, or 6? So that would be the cumulative distribution. So it's a probability distribution, and it's going to be, here's a shortcut. If I'm at the top and I arrow up, it'll wrap around, and I've got my binomials there. So this time I want a less than or equal. I want the cumulative, and so I'm going to select the binomial CDF, and we'll say enter. The number of trials is 25. The p-value, that hasn't changed, is 0.25. Now remember, we want a less than or equal to, so my x value would be, because I stuck with 6, it's less than or equal to 6. So this is going to give me the probability that x is less than or equal to 6. And we'll paste that in. So there's the command. It's binomial CDF, and what are the parameters? It's n, the number of independent repeated trials, the probability of success on any given trial, and the upper boundary here, the 6, is less than or equal to 6 successes. Press enter, and I see that probability is 0.56. So there's a little more than 50% chance that I'm going to get 6 or less of these questions correct. Now the last thing I want to do in this video is just to look at a normal distribution again. And let's suppose this is a normal with a mean of 98 and a standard deviation of 12. And suppose our question is, what's the probability that the random variable from this distribution is between 85 and 103? Now this is a problem that Minitab requires us to do 2 separate operations to get an answer. We'd have to calculate less than 103, and then calculate less than 85, and then take the difference. But the calculator will do all of that in one step, and let me show you how. We're dealing with the probability distribution, so we'll select distribution again. And it would be normal CDF because I want an area. So we'll get to normal CDF and say enter. Now the lower is negative infinity here by default, but it doesn't have to be. We can make the lower, you see the lower we really want in this problem is 85. So we'll replace negative infinity with 85. Now the upper in this problem is 103. And in this problem, the mean is 98, and the standard deviation is 12. And we're ready to paste. And so let's go ahead and paste it. And now what we've got, the thing that's off the screen here would be normal CDF, lower limit, upper limit, mean, standard deviation. So when we press enter, we're going to get the probability that a random variable with this distribution has a value between 85 and 103. So let's press enter, and we see that if X has a normal 98-12 distribution, there's a 52% chance that the value X takes will be between 85 and 103. And that's plenty for right now. So let me leave you at this point. I hope you find this helpful.